Up until now, we have used energies, particularly, I think, in very mechanical ways. What I'm talking about, in fact, is saying that ecological models, or the way that living systems work, are much more appropriate for this. So there is a design revolution that will occur whether we like it or not.
In the search for ecological approaches, the make or break point for these technologies is good design. But what if the solution was staring us in the face? What if nature itself held the answers? Biomimicry is the new buzzword for an ancient principle: nature-inspired design.
Biomimicry at heart is innovation inspired by nature. It's a process of learning from and then emulating life's blueprints, recipes, and relationship strategies. You can mimic form, which is the mimicry literally of a shape. So you might want to mimic the beak of a kingfisher, like they did in Japan. The bullet train used to be a bullet, and now it's a kingfisher beak shape because that's a very good shape for cutting through air and for going into a tunnel and out of a tunnel without any sort of a sonic boom.
One example of mimicking form is Dr. Tim Finnegan's ocean power systems.
I wonder what the water does.
So that's Newton meters, is it?
He's in the Ship Hydrodynamics Centre at the Australian Maritime College, using their wave tank to test prototypes of his tidal and wave power technologies.
The tuning seems to be okay, but you'll need to find a way to quickly measure the frequency. This is the BioStream tidal current power conversion system, and it's a biomimetic device that extracts power from a moving flow, such as a tidal current. It moves in an oscillating manner, much like a fish swims, but it takes power from the flow and generates electricity. We looked at the ocean and the environment and really thought from the very basic level, what can we deploy there that's going to work and it's going to stay out there for years and function reliably. A shark has evolved over billions of years to be very efficient at cruising and using the tail beat period to produce forward thrust. The lift produced causes this tail to shift back and forth against the load imposed by an electric generator, and that process generates power.
At the moment we're setting up the BioStream, again hooking up the machine so that we can do our first test run.
The full-size prototypes they are about to test in the ocean will be 20 metres high.
Yes, beautiful. Well, we put the model in and it's working, so you see it swims like a nice little fish. And that's really good, that's exciting.
Really, we're seeing more and more interest, more and more demand for large-scale installation. But eventually, you will see large wave tidal farms. It's gone past the point of being sort of speculative and kind of an emergent technology, and I firmly believe it's on the verge of widespread acceptance.
With Australia's access to large coastal areas, inventions like the BioStream are no longer the realm of science fiction. Cutting-edge innovation inspired by centuries of evolution could finally be part of our future.